Hi guys, so this is lab 2. I will talk lab 2 of Coursera data analysis with Python week 2. So basically we're going to talk about data wrangling. Okay, so basically you'll be able to like handle missing values, correct data formats, standardize and normalize data, and there's also like binning and then like dummy variables. Okay, so basically the purpose of data wrangling is to convert data from initial format to like format that is good for like analysis purpose. So first we're gonna need two libraries, pandas and matplot. Matplot is just to plot the data in a histogram or bar chart, and pandas. So for analysis purpose, we're gonna use the pandas. So this is the data. So let's run this first. Okay, and then this is the data set. I think it's an S3 bucket, CSV file. Name it as a file name, and then this is the headers. Let's run it. And then we're going to read the CSV file, the data set, and then since we have the headers, we're going to put it into names, and we're going to name it data frame df. Okay, so let's print out like few rows. Okay, this is it. So we have 5 rows here and 26 columns. So here, as you can see, there's like 3 missing data for normalized losses. So how we're going to handle missing values? So we're going to replace it with the nan, which means like not a number. So we're gonna use the dot replace. So we're gonna import the numpy library and then replace the question mark with the nan. So let's run this. As you can see, it's the 3 question mark is changed to nan. And we can also use this to check which contains the missing values. So if you use is null, you can see these 3 are true, which means these 3 are missing values. We can also iterate to see like all the missing values for all columns, how many like missing values for, yeah. And now there's ways you can deal with the missing data. So for here we could also drop the data, the whole row or the whole column. So we could replace the data by mean, frequency, or like based on some other functions. This is one of the example to like replaced by mean values. So first you calculate the average, and then you can change. So basically mean is average, right? So basically you're going to replace the not a number values with the average. So run it. Same thing with the other. This is just an example for the columns. Okay, and this is also same to replace by mean. Now you can see like how many values, how many value counts of for the, let's say for the number of data. And we could also use like ID max to see which has the maximum values or counts. So replacement with the most frequent is, you could just, since we found the most frequent 4, we could just replace with the 4. So could use the replace function, and then you can drop the value with nan, and then you could just reset the index. Okay, this is fine. Now let's suppose you have to like correct the data format. Suppose the data format is not correct, and like first to check it, you could just use d types. It just give you the data types, and then yeah, you could use as type to like change the data type. Now data standardization is basically like to make your data like transform into like common format, so it's easy for like meaningful interpretation. So here, let's say you could just do like subtract mean and then divide by the standard deviations. That's one of the ways. So basically it's like, for example, if you want to convert L per 100 kilometer to like miles per gram, you can use like this kind of formula, and then it will, in the code it will look like this. Yeah, this is pretty fine. And this is just an example. And then data normalization is basically to transform your values into like similar range. Let's say from, you want to change into like scale from 0 to 1. So basically it's like just let's say for the column length, you could just do like the original value and divide it by the max value. So same thing for the height. You can see all values is converted from 0 to 1. Now binning is process like transforming continuous numerical values into like some categorical bins. Let's say horsepower column is values are from 48 to 288, and you can like convert it into like high, medium, or little horsepower. So how you could do it, you could just first make sure your data type is correct. This is just to view your histogram, and then you can use the np.linspace start value, end value, and number generated. You can name the groups, and you can go use the cut functions, and basically, and it will look like this: low, medium, or high. And you can also count how many lows are there, medium, high. You can plot the bins like this. Basically, it will look like this. And so if you want to see the distribution of bins, basically we'll use the matplot libraries. Okay, you can label the X label, Y, and the title, and then histogram. Yeah, so if you want to find out the dummy variable or the indicator variable, basically it's you can use like get dummies for, let's suppose, for fuel type column. You can, for diesel, let's say you want to just get 0 and gas is 1, and you can just, after you do the get dummies, you could just rename it. It will look like this. And when you have this, you can just concatenate to the data frame, and then you can drop the original column. So if you want to look at here, you can see it's going to be 0 for diesel and gas for 1. And this is an example for other one. That's pretty much. And then if you want to save, you could just use df.2csv file. And this is for the lab 2. And that's all. So let me stop it. I'm gonna